Welcome to Tami's Maths. It's 11th standard and we are going to go for derivatives. Now I don't want to start with problems of derivatives. I would like to give a short introduction to the best that I can make it easy for you. Okay? What is derivative? What is differentiation? And how do we get the formulas? So I would like to discuss with you. Now let's talk about a curve which is continuous. What do you mean by continuous? There is no break. There is no break, the curve is just having a flow like that. That will be a continuous curve. Let's say I have a point P here which is x and y. I have a point P here which is x and y. Let's say that x has received an increment h. That is, x is increasing. That's what I say, increment. So x is now x plus h. H is the increment in x. Now I can discuss y in various ways, but I'll try my best to give you in a way that you can correlate with the book and work it easily. So now x is x plus h. It is always, the function is y is equal to fx. This curve is y, I said consider a curve. So the curve should have an equation, isn't it? So let us say the curve is y is equal to fx. Now when x is x plus h, y will be f of this. So this point will be x plus h, that is x coordinate, and the y coordinate is f of h plus x. That will be the y. There are various ways. I am trying that I can make it easy for you. That y coordinate there will be f of x plus h. In a similar way here, this y will be x and this will be f of x. Join PQ. This is a secant line. It's a chord, no? The chord is a secant line. Have it here. This angle is theta. Let's say this is OX. Let us have this angle as theta. Now from here, you draw parallel to x-axis, and from here you draw parallel to y-axis. This angle also will be theta. Now this length is the x-coordinate here minus the x-coordinate here. What is the x-coordinate here? X plus h. What's the x-coordinate here? X. So this will be h. Now what will be this? This will be the y-coordinate here. This is y full y and this y here. So this will be f of y here minus y here, isn't it? Y and y. That will be this line. Now tan theta is equal to f of minus f of x by h. This is tan theta. Now you imagine the tan theta is the slope of the secant line, theta. What is defined as slope? Go for analytical geometry. This is OX. The angle made by a line in this direction, in the positive direction of the x-axis, that is defined as slope. Now I'll give you a little extra information. Grasp it well. This line is called a rising line. And this line is called a falling line. When there is something rising and when there is something falling, there is always a rate at which it rises and a rate at which it drops down. There is always that. The rate at which it rises or the rate at which it falls down is actually the slope. Of course, we don't go to the deeper meaning of all that at any time, but that is actually the slope, and that slope is tan theta. Tan theta is the slope. And how do you define slope? Rate at which it rises, a line rises, or rate at which it falls down. All that we don't go for that, but we just say tan theta is slope. Now, this is the slope of the secant line. You imagine the point Q is moving towards the point P. You imagine point Q is moving towards point P. It will come here. It will go like that. It will go like that. So you find that H is decreasing. As Q moves towards P, H is decreasing. Of course, this length is also decreasing. But we can't discuss where both are becoming 0. Both are tending to 0. So I say when Q is moving towards P, this H is trying to become very small. This H tends to 0. So when Q moves to P, the limiting will be slope of the tangent line. When Q moves towards P, what happens? The secant line tends to become the tangent line. It tends to become the tangent line. So in the limiting position, Q will coincide with P and the secant line will become the tangent line. When the secant line becomes the tangent line, H will tend to 0. So that will be the slope of the tangent at the point P. It's like this. P is here. This is the tangent. It will be slope of the tangent at the point P. It will be like this. Slope of the tangent at the point P. So what is slope of the tangent at the point P? That is slope of tangent. Slope of tangent is limit of f of minus f of x by h, h is tending to 0. This limit is the slope, and this limit is called the derivative of this function fx. Suppose y is equal to fx, this limit is called d by dx of fx, or you can say d by dx of y, dy by dx. So what is dy by dx? The geometrical meaning of dy by dx. It is slope of the tangent at a particular point. Of course, we have a general way to talk about dy by dx also. And how is dy by dx given by? Limit of f of x plus h minus f of x by h, h is tending to 0. This is dy by dx. And dy by dx is a slope. The process you do is called differentiation. And what you get will be the derivative. This is the derivative, and this is how you get it. And getting derivative by this method will be called the first principle method. Okay. So now we will list the formulas, and one or two I will even derive and tell you. So we have to have a thoroughness in the mathematical part so that we will feel easy. Maybe it may take 2 or 3 extra videos, but you listen to those videos, derivatives will be made easy. So now, dy by dx is equal to limit of h is tending to 0, f of x plus h minus f of x by h, h tending to 0. This is actually dy by dx. Okay, that is what you call dy by dx. Now, we go for. That is what you call dy by dx. Now, I will take a small problem and I will work it and I will show you. How are we going to find out? How are we going to find out the derivative of y is equal to x square? How are we going to find out the derivative of y is equal to x square? dy by dx is equal to f of x plus h minus fx by h is tending to 0. What is fx? X square. So what will be h plus x? For x you will put h plus x. So this will be expanded x square will get cancelled with this x square. So this is limit h is tending to 0 to hx plus by h. So how can you write this as limit of h and h will get cancelled. So it is 2x h tending to 0 plus h squared by h will be h. That is limit of h tending to 0. This is 2x. There is no x at all, no. So what is limit of 2h when h tends to 0? 2x only. And this will be 0. So 2x plus 0, that will be 2x. So what is derivative of y is equal to x square? 2x. The process you have done is differentiation, and what you have arrived at is the derivative. So derivative of x square is 2x. So like that you can do everything. But I would like to go for one more also. We should never be in a hurry to work. All we have in our mind is the depth that we have to learn all this. The depth in which we have to learn all this. So we will see now. I am going to find out what will be derivative of y is equal to sin x. What is derivative of y is equal to sin x? dy by dx is equal to limit h is tending to 0 f of x plus h minus f of x by h. H tends to 0. What is f of x plus h? Y is sin x. That is, this is fx actually. So this will be limit h is tending to 0 sin fx minus sin x by h. H is tending to 0. Fine. Now sin c minus sin d it is. Sin c minus sin d. I will give a very easy way. Sin c minus sin d. Whenever it is minus, it will be 2. Write sign here. For sine, whatever sign comes, that should be put. And for cos, the other sign we should put. This is how we have to remember in a easy way. Sin c minus sin d, 2 sin c minus d by 2. And cos c plus d by 2. So when you have plus here, plus will come here and minus will come here. How do you remember? Yes, students, how do you remember? Sin c minus sin d, 2 sin. There's a minus here, there will be a minus for sin. And for cos, obviously it will be the other sign. And there's a plus here. For sin it will be plus, and for cos it will be the other way round. So now, this is limit h is tending to 0. 2 sin. This minus this by 2. H plus x minus x. That is h by 2. And cos. This plus this by 2. What is this? This will be limit of h is tending to 0 sin h by 2, this 2 bring down here, You can write it as h by 2. Can't you here? Write like that. This is 2x by 2 cos x plus h by 2. Now when h tends to 0, this limit is 1. This limit is 1. When I was teaching you limit, I was singing a song. Singing always makes you happy. It doesn't matter whether you know to sing or how sweet your voice is. That's not the concern at all. How does your heart goes with the singing? That counts. What is that I have been singing, or you two have been singing? What do I have here? The same thing should come here to make the limit 1. So this limit will be 1 and h is 0. So what will be the limit? Cos x. So what is that we have? D by dx of sin x will be cos x. The derivative of sin x will be cos x. The process you do, you differentiate. When you differentiate sine, what you will be getting? You will be getting cos. Like that, you can do all this independent, and this is called first principle method. Now, I am going to list all the formulas. It's not that you're going to do everything by the first principle method. You're going to remember everything now. Now, let me list all the formulas for you. I just did 2 by first principle method. If you want, you can go on doing. Now, after reading all this, whatever is in your book by first principle method, I think we can do that. So now, first, if y is equal to x power n, x square was 2x. I just did one small example for you. So dy by dx of x power n will be n into x power n minus 1. So you now learn to write it like this. D by dx of, what is y? X power n, and this is n into x power n minus 1. Correct. Next, d by dx of e power x will be equal to the same e power x. D by dx of e power x, all of this could be derived. D by dx of e power x is e power x itself only. D by dx of sin x will be cos x. D by dx of cos x will be minus sin x. D by dx of cos x will be minus sin x. Next, d by dx of tan x will be, d by dx of tan x will be secant square x. D by dx of cot x will be minus cosecant square x. Minus cosecant square x. D by dx of secant x will be secant x tan x. Next, see, differentiation is very important in its own way, and it is very independent also because we derive everything. But when I go for integration, it has no derivation and all. It is just an anti-process of this. So only if you are very good in this, you can do that well. And integration has a major role in your syllabus. In all the competitive exam and in your school syllabus also, it is having a very important role. So I suggest you read everything perfectly well. Okay. Next, d by dx of cosecant x is minus cosecant x cot x. Next we go e power x, sin x, cos x, tan x, and the reciprocals of this cot x, secant x, cosecant x. Then we go for d by dx of a constant. That will be 0. Why? There is no increment at all. No, it will be a straight curve. It's a straight line. It's a straight line. It's not like that. So d by dx of a constant will be 0. Next we go for d by dx of log x will be 1 by x. So you read all this, and in the next video I would like to go for further problems, and I would like to teach chain rule and all that. It will take some time. This chapter will take plenty of time. So what is the process you do? You differentiate. What is that you get when you differentiate? You get the derivatives. So we have dy by dx is limit h tending to 0 f of x plus h minus f of x by h will tend to 0. That is actually the derivative, and that is called first principle method. And the derivative of x power n is n into x power n minus 1 sin x sorry. Derivative of sin x is cos x. Derivative of cos x is minus sin x. Derivative of e power x is e power x. Tan x is secant square x. Cot x is minus cosecant square x. Secant x is secant x into tan x. Cosecant x is minus cosecant x into cot x. And derivative of a constant is 0. And derivative of log x is 1 by x. It is very necessary and very essential that you take a piece of paper and then practice all this by writing it. Like I ask you, what's your name? You answer without thinking. Like that you have to answer me. If I ask you what is derivative of sin x, like that you'll do? No way. You have to write what is derivative of sin x means. You have to say it should be an involuntary action to you. Like that thoroughness is there, only this calculus part could be done. And you have to see that you make it thorough. I can inspire you, but the fire in you should burn so that all this you will master it. Every time, every video I say master it. So in the next video we will go for more things about this. Till then, with a lot of interest, lot of enthusiasm, lot of love for mathematics, revise all this and come. In the next video we will go for more details about the derivatives.